Hello everyone, this is Ma'am Amano, and this lecture video is all about Newton's law of universal gravitation. This law answers the understanding of the force that caused the free-falling objects, air friction, particularly the celestial bodies, to move away the way they did. This law explains that. And then, it states that every object in the universe attracts every other object with a force directed along the line of centers for the two objects is proportional to the product of their masses, and inversely, meaning to say divide, proportional to the square of the separation between the two objects. So, this separation between two objects is the r squared, or the distance. So, these two objects here denotes the masses, and then the attraction here denotes the gravitational force. So, it can be expressed as this formula. Force of gravity or gravitational force is equivalent to the gravitational constant multiplied to the masses of the two objects over the r squared. So, sometimes this g here, this one, is written here as m1, m2 over r squared sometimes. And then the r squared is sometimes denoted as capital R, r squared. Alright? So, this F sub g here is the gravitational force. The m1 and m2 are the masses of the two objects. The r here is the separation between the objects, or the distance from the center, and then the capital G here is the gravitational constant. The value for the gravitational constant is capital G is equivalent to 6.67 times 10 raised to negative 11 Newton meters squared over kilogram squared. So this is the value for that. And then, for sample problem number 1, I have here two masses, 3 kg and 7 kg, are 2 meters apart. What is the gravitational attraction between them? So, on this case, you are given the following values from the problem. The mass 1 is 3.0 kg, second mass is 7.0 kg, the r, or the separation or the distance, is 2.0 meters. Now, the solution that we are looking here or gonna use is the force of gravity is equivalent to the gravitational constant multiplied to its masses over the r squared. We are using this because we are looking for the gravitational force from the problem here. This one, gravitational attraction that connotes the gravitational force. So, substitution, you will have here gravitational constant is 6.67 times 10 raised to negative 11 Newton meter squared over kilogram squared. Mass 1 is 3.0 kg, mass 2 is 7.0 kg. The distance or separation is 2.0 meter, then squared. And then, that is squared instead of sub 2. Alright, so next, you have to multiply this. 3 times 7, that is 21. Then law of sign, kilogram times kilogram, that is kilogram squared. Then here, you will have 4 raised to 2, then m squared, 4m squared. So, cancel of units, you will have to cancel this one and cancel the kilogram here as well. So, you will be left out with the Newton unit, which is the gravitational force unit, or the force unit rather. So, perform the operation, multiply, divide, you will have 3.502 times 10 raised to negative 10 Newton. And then, sample problem number 2, the gravitational force between two identical spheres is given as 8 times 10 raised to negative 5 Newton. The spheres are separated by a distance of 0.53 meters at the center. What is the mass of each sphere? So we have here, we are looking for the mass of the identical spheres. And we have here the gravitational force expressed as Newton, and then the distance or the separation. Again, the given values, we have here the gravitational force of 8 times 10 raised to negative 5 Newton, the separation distance of 0.53 or 5.3 times 10 raised to negative 1, that is 1, negative 1, alright? Or you may use 0.53 if you want, but I'm using here 5.3 times 10 raised to negative 1. They are the same either way. So, the formula that we will be using for us to find the mass is this one. Mass is equivalent to the square root of the gravitational force multiplied to its r squared over the gravitational constant. So, you will have here now substitution. The value of your force of gravity is 8 times 10 raised to negative 5 based on the given problem. Then, the distance of separation is 5.3 times 10 raised to negative 1. Then, square that. Then, the gravitational constant. And then, the next thing that you need to do is square this one. 5.3 times 10 raised to negative 1 squared. You will have 28.09 times 10 raised to negative 2 meters squared. And then, cancel of units here. you multiply this one, 8 times 10 raised to negative 5, then here you will have 224.75 times 10 raised to negative 7 Newton meter squared over the gravitational constant, then cancel the units, cancel the Newton, the meter squared. You will be left out with the kilogram squared. And then divide that, you will have 33.69 times 10 raised to 4 kilograms squared. Get the square root, you will have 5.80 times 10 raised to 2 kilograms. So this is the mass. And the next, you will have here, sample problem number 3. Miss Amano, whose mass is 60 kg, is doing a physics demonstration in front of class. She exerts a gravitational force of 9.78 times 10 raised to negative 8 Newton on 55 kg, Samantha, who is seated in the front row. How far is Samantha from Miss Amano? So you have here the mass, you have here the gravitational force, and then the second mass. So you will have here the given values like gravitational force that is being exerted is 9.78 times 10 raised to negative 8. Mass 1 is 60 kilograms. Second mass is 55 kilograms. You will be using this formula for you to find the distance or the r squared. But here we are looking for the separation, so we are using the d. Or it can be expressed as r squared as well. That is okay as well. Or r, just r. Alright? And then for solution, substitution, the gravitational constant G is this one, the masses, and then over the gravitational constant. Then, next is multiply 60 times 50, you will have 3,300 kilograms squared. And then, the next thing that you need to do is cancel of units. Cancel the Newton, cancel the Newton. You will be left out with the meter squared here. So, that is square root ha. I forgot to put that. And then next, divide, you will have 2.25 meters squared. Get the square root, you will have 1.5 meters. So, that is the answer for that. Now, for your practice exercise, sagutan nyo lang to. Hindi nyo kailangan ipasa sa akin. Pag-practicean nyo lang, ha? Alright. So, that is all for this lecture video.